Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, we are still going through the Euclidean geometry exam type questions, and we are going to be focusing on example 3, which asks us to prove that this shape or this is a cyclic quadrilateral. And we'll also be focusing on example 4, right? And example 4 tests to see whether we understand most of the Euclidean geometry theorems. For example, we have a cyclic quadrilateral in this question, right? We have an exterior angle of a cyclic quadrilateral. We have parallel lines, right? We have a center to the circle, right? We have a diameter, right? So this question tests most of the theorems that you guys are assessed on Euclidean geometry. So it's great practice to just see how you're supposed to apply the whole Dr. Cape Town to help you just approach this whole question, right? So it is a great question to just help you in gathering your thoughts and just to show you step by step how you're supposed to answer this question, because it is a detailed diagram, right? So you need to be able to break the diagram down by looking at what you're supposed to look at. Do you have a diameter? Do you have a radius? Do you have a cyclic quadrilateral? Do you have parallel lines? Do you have tangents, right? So I'm going to be showing you guys how you're supposed to approach this question so that it doesn't confuse you, so that you don't know what you're doing. All right, guys, before we get started with the video tutorial, please make sure that you are subscribed to the channel. Please make sure that you give this video a huge thumbs up, because it really helps the channel grow and it helps the channel reach more learners that want to better their mathematics. And also please make sure that you hit the notification bell so that you get notified every time I upload a new video. All right, guys, so without any further ado, let us get started with this video tutorial. Okay, guys, so like I said, we're going to be going through example 3, and example 3 asks us to prove whether this shape, right, that PPTSR is a cyclic quadrilateral. Before we get started, guys, please make sure that you just copy down this diagram, and once you've copied it down, you'll be able to follow with me when I show you the steps you're supposed to take to prove that this is a cyclic quadrilateral, right? Copy it down, and then once you've copied it down, play the video to see how I prove that this is a cyclic quadrilateral. Okay, so let's have a look at the question. In the diagram below, O is the center of the circle and PTSR is a cyclic quadrilateral, right? Prove the theorem that states that P plus S is equal to 180 degrees. So now let us start with the approach or how you're supposed to prove this theorem, right? So this is saying that you need to prove that P plus S is equal to 180 degrees, right? So you want to prove that these opposite angles, right, when you add them, you will get 180 degrees. So for this question, or when you're required to prove a cyclic quadrilateral, guys, I need you guys to focus on which two angles do they want you to prove. So they want you to prove P and S, right? So you don't draw a construction line from the angles that they want you to prove. However, you're going to draw construction lines from the other two opposite angles, right? So the first thing we're going to do is we're going to draw construction line.
So like I said, guys, we are going to draw construction lines from the center to the point R, and we're going to also draw another construction line from the center to the point T. Okay, so let us get started with that. Okay, so the first construction line, we're going to draw it from the center to the point R, and the other construction line, we're going to draw it from the center to the point T, right? So from these construction lines that I've just drawn, is there something that you guys can see, right? From here, guys, we can see that the angle that is at the center has been split into two, right? There's now angle O1 and there's also angle O2, okay? So since now we see that we've got an angle at the center, which theorem comes to your head that talks about an angle in the center? The theorem that we can think of that talks about the angle at the center and an angle at the circumference is the theorem number 2 that I discussed in my Euclidean geometry summary that talks about the angle at the center is equal to 2 times the angle at the circumference, right? So we've got the angle at the circumference here, and that angle that is on the circumference is our angle P, and the angle at the center is our angle O2, right? What about the other angle? Okay, we can see that for the other angle, the angle that is at the center is our angle O1, and the angle that is at the circumference is our angle S, right? So how can we basically use what I've just drawn on my diagram to help us derive the formula for opposite angles that are in a cyclic, quadrilateral, or supplementary? What do you guys notice here in the center? We basically notice that this angle O1 is making a revolution, right? And one revolution is equal to 360 degrees. So if we add angle O1 and angle O2, we should get 360 because this angle here is making 360, right? So we're gonna write that. Angle O1 plus angle O2 is equal to 360. Okay, and then guys, what else did I just highlight to you guys? We said that because we see that we've got an angle at the center, or we've got angles at the center, right? That highlights the theorem that talks about the angle at the center is equal to 2 times the angle at the circumference. So we're going to write that down. The angle at the center is angle O1, right? And that theorem states that the angle at the center is 2 times the angle at the circumference, which is S, right? So the angle that is at the center is 2 times the angle that is at the circumference, because basically for this one now, for our angle S, we will just be focusing on, okay, we will be focusing on that angle there, okay? And that angle is angle O1. And the angle at the center is equal to 2 times the angle at the circumference, right? So what about our angle P? For our angle P, we are going to be focusing on that part of our shape, okay? And that part of our shape, the angle that it makes is that angle there, right? So O2, our angle O2, angle at the center, which is O2, is equal to 2 times the angle at our circumference, which is angle P, right? And then the reason that we give for this is angle is equal to 2 times the angle at the circumference, right? So now how do we put these two things together, right? So we're basically going to say this is our equation 1, okay? And these are the equations that we are supposed to substitute into our equation 1. And once we've substituted those equations into our equation 1, then we would have been able to prove this theorem. Okay, so let us substitute. Okay, so we said that O1 plus O2, angle O1 plus your angle O2 is equal to 360 degrees. Né? And then what is our angle O1? We found that your angle O1 is 2S, right? And then what is our angle O2? We said our angle O2 is 2P, right? And that is equal to 360 degrees, right? We can see that we've got a common term, which is number 2. We're going to take out that 2, and you'll be left with S plus P, which is equal to 360 degrees. And then if you divide by 2 on the left hand side, and you also divide by 2 on the right hand side, you will find that angle S plus your angle P is equal to 360 divided by 2 is 180 degrees. So that is the same as saying P plus S, which is equal to 180 degrees. And from here, guys, we have proven the theorem that states that opposite angles of a cyclic quadrilateral are supplementary. In other words, those opposite angles add up to 180 degrees, right? So the first thing, guys, just a quick recap of what we just did. The first thing that we did here is that is that we looked at what the question asked us to prove, right? And the question asked us to prove that angle P plus angle S is equal to 180 degrees. And I gave you guys the hint that if they're asking you to prove that these two angles are supplementary, then when you draw your construction lines, you need to draw the construction lines from the other two angles that they didn't ask for, right? From there, guys, I showed you that you're supposed to draw your construction line from your angle, from the center to your R, and from the center to the T, right? And then from there, guys, what did we notice? We noticed that our angle that is in the center has basically been split into two, right? And we now have angle O1, and we also have angle O2, right? And then from there, we could remember, or we could think of a theorem that spoke about an angle at the center and the angle at the circumference, right? We saw that, okay, cool, we've got an angle at the center, which is O2, and we've got an angle at the circumference, which is P. So that angle at the center is going to be equal to 2 times the angle at the circumference, right? Another thing we also saw is that the angle at the center, which is our O1, is also going to be 2 times the angle at the circumference, which is S. And then from there, guys, we could just simply substitute those equations into each other to help us prove that P plus S is equal to 180 degrees. So that is how we prove the cyclic quadrilateral theorem that states that the opposite angles of a cyclic quad add up to 180, or opposite angles of a cyclic quad are supplementary. Okay, guys, let us go to the next question. Alright, so let us have a look at example 4. And before we even get started with example 4, guys, pause the video, copy down the question, try it on your own, and once you've tried it on your own, play the video to see if you were correct in your approach. Alright, so please make sure that you do that, guys. That is the most effective way that you are going to learn. Okay, so let us get started. Example 4, let us read what the question is asking from us. So example 4 says, in the figure, QS and PR are diameters of a circle with center O such that PQ is parallel to SR. PS is produced to T. N is a point on the circle such that Q1 is equal to Q2. SN is drawn. RS intersects QN at M, and S1 is equal to 48 degrees. So that is the information that we have been given. Let's just highlight the important details that we have been given. Number 1, we are told that QS as well as PR are diameters of the circle. The second information that we're given, we're told that PQ is parallel to SR. We are told that point N is a point that is on the circle. And then we are also told that Q1 is equal to Q2. All right. And then RS intersects QN and at M. And we're also told that S1 is equal to 48 degrees. Right. Okay, so let us have a look at question 1, right? Question 1 asks us to determine with reason the size of Q1, right? So like I mentioned, guys, in my previous videos, is that we always need to think of the acronym Dr. Cape Town when we are solving our Euclidean geometry questions, right? Okay, and we need to think, if I obviously have a diameter in the diagram, how will that help me answer the question? If I've got radius, how will that help me answer my question? If I've got a cyclic quad, how will that help me answer the question that they want me to answer? If I've got parallel lines or tangent lines, how will that help me answer the question that they're asking me, right? So in this case, they're asking us to determine the size of Q1, okay? That is Q1, right? So now we need to go through this acronym to see if, will any of these help us find the value of Q1? Okay, let's start off. Do we have diameters in this question? Yes, we definitely do. We know that PR is a diameter, but that is not going to help us solve anything, because with that, we just know that because PR is a diameter, right, the angle that is subtended by the diameter, right, which is the angle S there, is 3, and 4 is equal to 90 degrees. So that one is not going to help us with anything. So let's have a look at R. Do we have a radius or radii in this question? We definitely do. OR is a radius, OQ is a radius, OP is a radius, and OS is also a radius, right? But that is also not going to help us with anything, because that is just not going to help us with anything because we're not given information. If we were given probably the angle there, right, then we were going to be able to basically say that OP is equal to OQ, because it's equal radius. Therefore, that means we've got an isosceles triangle. Therefore, that will mean that we've got opposite angles of an isosceles triangle are equal. But we're not given that information there, so that's not going to help us with anything. Do we have a cyclic quadrilateral in this question? We definitely do have a cyclic quadrilateral, because P, Q, N, and S, right, is a quadrilateral. So 4 sides are inscribed in this circle, so it is definitely a cyclic quadrilateral. Will that help us answer the question? Yes, we've got a cyclic quadrilateral. We do not have opposite sides. Opposite angles are not given. However, this cyclic quadrilateral, we are given an exterior angle. So what do we know about an exterior angle of a cyclic quad? An exterior angle of a cyclic quad is equal to the opposite interior angle, right? So then we can see that, oh yes, there we can use that theorem to help us get to that answer, right? Because if we find the value of Q, then we are given information here that Q1 is equal to Q2, then we can move forward. Okay, so now let us just apply all that I've just said now. So like I said, we do have a diameter, we do have a radius, we do have cyclic quad, and we also have parallel lines in this question. For now, we do not have tangents, so that's not going to help us with anything. And like I mentioned, that the theorem about the cyclic quads is going to help us answer this question, because we notice that we've got an exterior angle, right? So this is our cyclic quad. I'm highlighting it in yellow. And that is our exterior angle there. And our exterior angle of this cyclic quad is equal to 78 degrees, right? And then what does the theorem say? That an exterior angle of a cyclic quad is equal to the opposite interior angle, right? So then we know that for A, we can say that angle S1 is equal to your angle Q, which is equal to 48 degrees, right? Because what? We've got an exterior angle of a cyclic quad. Okay? So then from there, what other information is given to us, guys? We are given that Q1 is equal to Q2. So how is that going to help us? That just basically tells that whatever angle we have there, that angle should be equal to that angle there, right? So if we already know that this whole angle there is equal to 48 degrees, that means that to get your angle Q1, we just need to take your 48 and divide it by 2, right? So we were given the information that Q1 is equal to Q2, right? And you can say that this is given, okay? Therefore, to get your angle Q1, we are basically going to say 48 divided by 2, which is equal to 24 degrees, okay? And the other tip that I gave you guys is that you need to basically put that angle on your diagram, because that is going to help you in the future. Okay, so we're going to put that angle there is equal to 24 degrees, and you're going to put that angle there is equal to 24 degrees. Okay guys, so we've basically answered this question. Let us move on. So in the next question, question B, we are asked to determine with reason the size of R. Yeah? So that is the angle that they want, and they want us to give reasons. Okay, so let us see what is going on with R. Knowing the diameter is not going to help us with anything. Knowing the radius is also not going to help us with anything, because I mentioned that we at least need the value of S3 to be able to get the value of R, because like I said, because we've got a radii or radius, OS will be equal to OR, right? And then we know that opposite angles in an isosceles triangle are equal. Therefore, if we had S3, we were going to be able to find out what our R is. So in this situation, we do not have the value of our S3, okay? But I just saw something, right? because we know that if you have the angle QS, right? If we look at QS and we know that QS is a diameter, what does that tell us about your P? That tells us that our P is a right angle triangle, and then we could use sum of angles in a triangle to find out what our S4 is, right? And once we have our S4, we already know that that whole S3 plus S4 is equal to 90 degrees. Then we would be able to find your S3, and then if you have your S3, you would be able to find R, because like I said, this is an isosceles triangle because the radii are equal, and then from there R will be equal to S3, right? But if that is too much of a procedure for you and you're not liking that one because it's just too much work to do, there's also something that I am noticing here, right? What am I noticing, right? I'm noticing that your angle Q1 and your angle R are angles that are in the same segment. Why am I saying that the angles that are in the same segment? Because that angle Q1 and the angle R are subtended or connected by one arc. Therefore, it makes those angles equal. So from there, that just makes our life so much easier, right? Because we just know that Q1 is equal to R, right? Because they're angles that are in the same segment. Okay, so like I said, your angle R is equal to Q1, and the reason is you've got angles in the same segment, right? Okay, so that makes it 24 degrees. So your angle R is equal to 24 degrees. Okay, and we are basically done, right? And guys, just before we go on to calculating M1, please do not forget to put in your angle R, right? And we found that it's 24, because I told you guys that you need to always just put down all the values you've calculated on your diagram so that you see what you have, and then from there it'll help you calculate probably the next angle that you guys are required to calculate or find. Okay, so now let us look at M1. Determine with reason the size of M1, right? Okay, so from here, guys, the diameter, so this is our M1, so we want that angle there. What are we noticing, guys? We have parallel line, right? So what can we think of when we think of parallel line? Corresponding angles, right? So with corresponding angles, if you have an angle there and an angle there, those angles are equal, right? So let us have a look at what is going on here with our M1. Okay, we've got that F situation going on there, right? That is the F, right? We have an angle there. Okay, so that is our F. I'm sure you guys can see it, right? And then we have that angle there, right? And we found that the angle Q was equal to 48, because 24 plus 24 is equal to 48. And look, what do we see here, right? There, right? So angle Q is equal to angle M1, right? Because we've got parallel lines and we've got corresponding angles, right? So let us go to C, right? So from C, we can say that angle Q is equal to our angle M1, which will be equal to 48 degrees. And what is the reason for this? We have corresponding angles. Okay, or you can just say QP is parallel to RS. Okay, and then we've basically found the value of our M1. Straightforward and easy to do, right? Because let's also think about this, right, deeply, guys. If you were thinking, okay, I've got an angle there, maybe I need to do but that is really not going to help us with anything, guys. We were going to be stuck. If we were going to get all these angles that are going on there, that is not going to really help us much, because it would get to a point where we need to get what our M3 is, right? And because we are told that RS intersects QN, that would mean that those two angles would be equal. Our M3 will be equal to M1. But it was going to be extremely hard for us to get M3, guys. It was going to be really difficult for us to get to that point. Okay, it was going to be like a lot of work. And can you please look at the mark allocation? It's 2 marks for us to be going around calculating some of all these triangles there. It is going to be a lot, right? But then, because we see that there's parallel lines, guys, if you see that there's parallel lines and you can see that something is becoming a long story, then you can just simply look for corresponding angles, look for alternate angles, look for co-interior angles, because then that will just make your life simpler. And in this case, we found that, oh, okay, we've got corresponding angles. That angle there is equal to that angle there, and that is simple. We can simply solve our question. Okay, another also clue that you guys also need to remember for corresponding angles, right, is that another situation that you might be given is you might be given the angle there at the top, right, and then that angle at the top would be equal to that angle there. Okay, so you need to remember this when you're working with corresponding angles, because it will really make your lives that much simpler. Okay guys, and then let us have a look at the last question, right? And the last question asks us to prove that ST is a tangent to the circle passing through M, N, and S. So I've basically erased everything here just to help you guys see what is going on, right? So they're telling us that we need to prove that ST is a tangent, right? So that is our ST there, right? And they want us to prove that it is a tangent to the circle passing through M, N, and S. So they're telling us that there's a circle. We're not seeing that circle, but the circle is there, right? So what does that tell you guys? You need to draw this circle, right? And this circle must pass through points M, N, and S, like that, right? Okay, right? So that is the circle that we have. Let me actually make it in red, right? So that is our circle that we have. It passes through point M, it passes through point N, right? So that is the circle that they're talking about. It's passing through this point, and for the line ST to be a tangent, that circle needs to touch that line ST only at one point, right? So that is what I have there for you guys, right? And then I'm just simply going to basically draw what we are going to be focusing on, right? So now we are told that we've got a tangent now. We've got a tangent that is involved in question 2, right? We've got a tangent here, right? And then what does the theorem say when we have a tangent and we have a chord, right? Okay, we can see that point SN is a chord to this new circle that we have, right? We can see that SR is another chord to the circle that we have, right? And we are told with this theorem that an angle that is formed by a chord and a tangent is equal to an angle that is in the alternate segment, right? So M1 will be the angle in the alternate segment. Let me show you what I've basically mean, guys. I'm going to draw another diagram to help you guys understand what I'm talking about. Okay, so that is what we have. We've got a circle, we've got a tangent, okay, we've got point S and M, and we've got M and N, right? And then let's just label this diagram, right? We've got point S there, right? We've got point M there, and that point S, that is basically the point M1 that we found there, right? And we've got point N, right? And then this is our ST, that is just our tangent, right? So what does the theorem, the tan chord theorem say, right? The tan chord theorem says that, so this is your tangent, which is your ST, and your chord, which is your SN, form an angle, then that angle is going to be equal to an angle that is in the alternate segment, right? We already found that our the angle S1 is equal to 48 degrees. Okay, that angle there is equal to 48 degrees, right? And then we also proved that that angle there was also equal to 48 degrees, right? So now from there, how do we prove that ST is a tangent to the circle passing through M, N, and S? It is a tangent based on the tan chord theorem, right? So number 2, M1, we found that it was equal to 48 degrees. S1 was also equal to 48 degrees, right? And we can see that M1 is equal to S1, which is equal to 48 degrees. And this is the reason that we have based on the tan chord theorem. Okay, so we've basically proven that ST is a tangent to the circle because we applied the knowledge that we have about the tan chord theorem, that if you have an angle that is formed by a chord and a tangent, right, a chord, and a tangent, then that angle will be equal to an angle in the alternate segment, which is that M1, which is equal to 48 degrees. So therefore, that does prove that ST is a tangent that passes through points M, N, and S. Okay guys, that is it for today's video tutorial. I hope you guys enjoyed the video tutorial. I hope I made everything easy and straightforward for you guys. Please make sure that you are subscribed to the channel if you're not, and guys, please don't forget to give this video a huge thumbs up. The next video that is coming up is the proportionality theorem. I'm going to be explaining what the proportionality theorem is, giving the proof of the proportionality theorem, and I'm also going to be taking you guys through one example just to help you apply the theorem that I would have explained to you guys. So please make sure that you are subscribed to the channel, and also make sure that you click the notification bell so that you get notified when I upload that video tutorial. That is it guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye guys.